Okay, this is Web Assigned 7B, problem number 3. Pascal's binary system consists of two stars that revolve in a circular orbit by a center of mass in between them. This statement implies that the masses of the two stars are equal. See figure below. We'll assume the orbital speed of each star is v is equal to 230 kilometers per second, and the orbital period of each is 14.5 days. Find the mass m of each star. For comparison, the mass of our sun is 1.99 times 10 to the 30th kilograms. Okay. So first we're going to start off with our forces. So we're actually going to start off with Newton's first law right here. Ready? It's going to be F is equal to ma. But we are in space, so A is equal to V squared over R. Now what I mean by we're in space is the centripetal acceleration. So F is actually equal to mv squared over R. Now we can also use Newton's law of gravitation here. It states FG. G is equal to gm squared over, well actually no, it'd be gm1 times gm2, but seeing as it said the masses are the same, it's gm squared here. All over, squared. And now, since they're both FG, we can set them equal to each other to get mv squared over r. And now these m's and these r's are the same. So we can actually solve for a variable here. So then we can solve for our m, being that m is equal to 4v squared times r over g. But we're not done. Here we need to understand the fact that our radius is actually equal to our velocity times our period divided by 2 pi. And the reason it's over 2 pi is that it's one full trip around a circle is equal, like on the unit circle it's 2 pi, one trip around, so here it's 2 pi around. So our r must be equal to vt over 2 pi, and that t is our period, and that v is our velocity. And then we plug that in for our r, so it becomes m is equal to 4v squared over g times vt over 2 pi. And now our 2 and our 4 cancel, so we get m is equal to 2v cubed now, because we're multiplying by v's, equal to g pi. And this looks pretty funky. Me, myself, I did not, at this point, I was like, yeah, this is definitely wrong. But that g value is our gravitational constant, in case you're wondering where that came from. Our velocity is the velocity we're given, our period is the period. Well, actually, not the period we're given. We're going to have to do a little conversion for our actual period. Okay, so we got to this point. Now, we have m is equal to, now we have to plug in our velocity. The velocity is 230 kilometers per second. We need that in meters per second. So m is actually equal to, and then don't worry about that too. So it's twice 230 times 10 to the third, and then this is actually cubed. Let me not forget about my units. This would be meters per second cubed multiplied by, now this is our conversion, so we got 14.5 days times 24 hours in a day times 3,600 seconds in an hour, all over our gravitational constant, which is 6.67 times 10 to negative limit. And off the top of my head, I cannot remember the units, but you can, they have to cancel. Okay, so we can actually times 10 to the negative 11th times pi, and pi would be, your calculator's best approximation of it. And then we clear all that out. We actually do not get the answer we need, because as of right, this is some number to like the 32nd power. Now it wants us to divide that by that amount of, because that's what the mass of our sun is. It wants to know how many masses of our sun this planet exists. So then once you get this entire thing is actually all over that 1.99 value to find how many of this one it actually is. So if you cancel it with your gravitational constant and everything in the numerator, your answer should come out to being over kilograms. And then once you divide by the kilograms, that's where your kilogram drop out into solar masses. So once you actually do divide this final answer by 1.99, you should then just be getting your clean 73. So what we did was we found what the force squared is equal to using our centripetal acceleration because we are in a rotating system. Then we equaled that to our Newton's formula. And then we just solved for our variables and plugged everything in. So I hope that helped.